Two identical point charges, each having magnitude q, are placed as shown in figure. There are two identical charges q. 2a is the distance between the charges. As we move away from center along x-axis, this is our x-axis, then field first increases, then becomes constant. As we move away from center along x-axis, then field first increases, becomes maximum at a point, and then start decreasing. Okay, so first two options are based on the electric field. Okay, and see, if we place a negative charge of magnitude minus q and mass m at the midpoint of the charges here somewhere, and displace along x-axis by a distance 4a, which is 4a somewhere here, and release, then it will perform SHM. So let us investigate this particular question. So first of all, let us find the electric field at a distance x from the center. Okay, so here is the first particle. So electric field due to the first particle will be along the line joining and away from the positive charge, because this q is positive. And similarly for this particular q, the electric field must be away from this also. Let E dash be the magnitude of electric field due to these two charges, and obviously the resultant electric field E will be directed this way along the bisector of the two, because these two are equal electric field vectors. So E dash is equal to 1 upon 4 pi epsilon naught into charge divided by square of the distance. So what is the distance? This particular distance is x, this is a. So here it is under root a square plus x square and whole square. So this is the electric field E dash, and suppose this angle is theta, then the vertically opposite theta. So net electric field E at this point will become 2 E dash cos theta, as you can clearly see. Theta, E dash cos theta, E dash cos theta, added sin theta components are cancelled with each other. So 2 times E dash is q divided by 4 pi epsilon naught into a square plus x square, because of the whole square under root has vanished, into cos theta. Cos theta is x divided by under root a square plus x square, as you can see here in this particular triangle. So net electric field E becomes 2qx divided by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. So this is the net electric field. Okay, so how this electric field is going to change? As you can see here at the center, clearly the electric field is going to be 0. And as we move away from here, the electric field is going to first increase and then decrease to 0. You can analyze this particular function. Let us assume that y is equal to x divided by a square plus x square raised to the power 3 by 2, and analyze this function. Then the graph that we'll get will be somewhat like this. Means at a particular distance, this field will become maximum. The value of the y will become maximum. For that you have to differentiate y with respect to x and then put it equal to 0, and then solve for what value of x y is going to be maximum. And it is clear as we move away and away from this configuration, the field is going to decrease because of the increase of the distance. It cannot remain constant. So first option is absurd. So second option has to be the correct option. Now, if we talk about the option C, we place a negative charge of magnitude minus q and mass m at the midpoint of the charges and displace along x-axis by a distance 4a. As we can see that suppose particle is somewhere here, then force of attraction, because this is given to be the negative charge, force of attraction acting on this particle F will be given by F equal to charge q into electric field. Electric field is 2qx divided by 4 pi epsilon naught a square plus x square raised to the power 3 by 2. As you can see, this force can be proportional to x only if x is much smaller than a. Okay, but here it is given that distance x is 4a. So it cannot be a case of SHM. It is an oscillatory motion. If we release this particle from this position, it will start oscillating about the center point between these two charges. But clearly this is not going to be SHM, because for SHM here in this condition, SHM is possible only if x is much smaller than a. So only option B has to be the correct option to this question.